Oh, good morning and welcome to School of Chemistry. My name is Abi Moses Ogo. If this is your first time of visiting this channel, please click on the subscribe button and turn on the notification bell so that anytime we drop new content, you'll be able to follow up. And today, we'll be looking at IUPAC Nomenclature of organic compounds. But before we continue with that, let's look at the electronic configuration of carbon. Carbon has atomic number 8. So there will be two electrons in the innermost shell for the electronic configuration and 4 electrons in the outermost shell. For every compound that exists in nature, we all know that it is an attempt by the combining element to attain stability. And stability is either the duplex state or the octet structure of the noble gases. So for carbon now, we have a tetravalence. That means it needs 4 electrons to attain the octet structure of the noble gases. So carbon can do this by either electrovalency or covalency. But in organic compound, majorly what we see is covalent bonding, whereby there is sharing of electron, which can be ordinary covalent bonding or additive covalent bonding. So when carbon atom goes into combination to form compound, it's trying to satisfy this structure by what? Sharing 4 electrons in diverse way to attain stability. So when this 4 electron comes in by single bonding, we'll have it like this. It can come in by double bonding in this nature. It can come in by triple bonding. Now, if you count, you have 1, 2, 3, 4. 1, 2, 3, 4. This is the 4 bonding, and it satisfies what? The tetravalence of carbon. Here we have 1, 2, 3, 4. Okay, this is not correct. It must not be more than 4. The bonding of carbon cannot be more than 4 because it is just 4 electron it needs. 1, 2, 3, 4. And here too is not correct. 1, 2, 3, 4. Now, in this case, I am equally not correct. So per time, when you are writing the carbon structure both in inorganic or organic chemistry, the carbon atom cannot take more than 4 bonds. Here we have 1, 2, 3, 4. Here we have 1, 2, 3, 4. So it can either go into bonding by what? Single carbon bonds, double bonds, or what? Triple bonds, depending on where it is. So now, in naming organic compounds, trying to name organic compounds, how do we name them? Now, we name them depending on their what? Number of carbon that it has. Now, for a carbon compound that has just 1 electron, for a carbon compound with just 1 carbon atom, we'll call it met. For a carbon atom with 2 carbon atoms, we'll call it et. Carbon atom with 3 carbon atoms is prop. Carbon atom with 4 carbon atoms, but 5 carbon atom is pent. 6 carbon atom is hex. Hex. H-E-X. 7 is hept. 8 oct. 9 carbon atom is non, and 10 carbon atom is dead. So depending on your number of carbon atom will determine the name of the compound. So we say for 1 carbon atom you call it met, 2 is et, 3 prop, 4 put, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Now, remember we have this series. When we study the homologous series, the alkali and the functional groups, we have different homologous series that are determined where their chemical property is determined by the functional group and the physical property is determined by the what? Alkyl group. So we have the alkanes. So studying the alkanes, okay, we'll have the alkanes, the alkenes, the alkynes, the alkanols, the alkanals, and the alkanones, and so on. Now, in studying this, the difference is just their functional group majorly. Now, in the alkanes, we have the carbon-carbon single bond. In the alkanes, we have the carbon-carbon double bond. In the alkynes, we have the carbon-carbon triple bond. In the alkanols, we have the COH. It's the presence of the OH that makes it an alkanol. Now, in the alkanals, we have the C double bonded O bonded to H. It's the presence of the O and the H that makes it an alkanol. And for the alkanones, we have C double bonded to O. It is the presence of just this double bonded to O that makes it what? On the functional group that makes it an alkanol. So we'll be looking at this one. How do you name them? Now, for the alkanes, let's start with the alkanes. Let's start with the alkanes, for instance. The alkane series, how do you name them? For the alkane series, we have one carbon is met. So the first member with one carbon is not bonded to it, so we definitely satisfy this. It's just carbon, they are called hydrocarbons. And hydrogen, this is CH4. You can study our molecular and the structural formulas of organic compounds in one of our videos. So we'll call this met, and because it's an alkane, we'll add ANE, it becomes methane. The second member with two carbons like this, we have 3 hydrogen attached to this to make it 4. So we have 1, 2, 3, 4. 1, 2, 3, 4. So that is et. And because it's an alkane, we'll call it what? Ethane. Where all the single bonds are just, everything is made of a single bond, it is called an alkane. And you represent it by simply adding your ANE. Now for 3 carbon, 1, 2, 3. 1, 2, 3. 1, 2. 1, 2, 3. Let's count. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Can you see that? Everything must have 4, 4, 4 carbon. We'll call this propane. 4 carbon atoms. 1, 2, 3, 4. Instead of writing 1, 2, 3, I'll just put CH3 here. I can put H2 here, H2 here, and H3 here. And this will become butane. Now, for the 5th carbon, pent, gonna be pentane. 6 will be hexane. Pentane will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I put 3 hydrogen here, 2 hydrogen, 2 hydrogen, 2 hydrogen, and 3. For hexane, 1, 2, okay. I think I can write it like this now. 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. This is hexane. For heptane, which is 7 carbon, hept is for 7. So I'm going to have H3, C, CH2, 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 1, 2, 3, 4, 5. Still need 2, CH2, CH3. Octane, that is the 8th carbon. 8th carbon is oct, because it's an alkane, we'll put ANE and becomes what? Octane. C, H, no, we can do CH8, H18. We have nonane, and then decane, and their formulas. So this is how to name the alkanes. This is how to name. Simply get the number of carbon atoms. Here is 1 carbon. one carbon, you name it, and then add met, add AN because the alkane becomes methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane. Now, let's look at the alkane series. The alkane series. We have studied the alkanes. Let's look at the alkane series. Alkenes. The difference between the alkenes and the alkane is the presence of the double bond. The double bond, carbon-carbon double bond. In the alkenes, it's carbon-carbon single bond. In the alkanes, it is what? Carbon-carbon double bond. So looking at the alkenes, for a carbon double bond to exist, it cannot exist with one carbon, it must start with two carbon. So we don't have a first member called methane. It starts with et. So now, for the first carbon, we're going to have carbon-carbon double bond. And when there are two carbon, it is what? Et. Now, because there are double bonds, I now have one bond, that is 3, 4. Here is 1, 2, 1, 2, 3, 4. And that is my first member of the alkene series. And because it has a double bond, I'll come and name it ethene. Now, for 3 members, 1, 2, 3, here will be 1, 2, 1, 2, 1, 2, 3. 1, 2, 3. Because it has 3 carbon, it is pro. And because it has a double bond here, it's going to be propene. Now, 4 carbon atom. For 4 carbon atom, but 1, 2, 3, 4. A double bond here. 1, 2, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is our but, but it has a double bond, so it's going to be what? Butene. I'll have pentane, hexane, heptane, octane, nonane, and decane. Now, let's look at the alkyne groups, the alkynes group, the alkyne series. What makes the difference from the alkanes and the alkenes? The alkanes, like we said, have a single bond. The alkenes have double bond, while the alkynes have triple bond. Now you can see that the level of unsaturation is increasing with the increase in the number of bonds. We say the alkanes are saturated, the alkenes are not saturated, and the alkynes are not saturated. So we'll call the alkenes and the alkynes, we'll call them unsaturated hydrocarbons, while the alkenes are called what? Saturated hydrocarbons. Now let's look at the first member of this series. Because there's a triple bond, that's what makes the difference in the alkynes, the presence of a triple bond. In the alkenes is the presence of the double bond. In the alkynes is the presence of what? The carbon triple bond. This is what makes the difference. So for the first member, 1, 2, 3. This is the first member with 2 carbon. It has 3 bonds already. So I only need 1 more bond. So because it's a hydrocarbon, you have 1 hydrogen here, 1, 2, 3, 4, 1, 2, 3, 4. And this becomes your ethyne. 1, 2, 3. For the third member, I'll have 1 here. 1, 2, 3, 4. This doesn't need any hydrogen, is satisfied. 1, 2, 3. And this is going to be my propane. For the fourth, I'll have 1, 2, 3, 4. 1, 2, 3. So I'll have 1 hydrogen. This doesn't need 1 hydrogen. 1 hydrogen. 1, 2, 3. And this is my butane. For the fifth, I'll have 1, 2, 3, 4, 5. So this is going to be 1, 2, 3, 1, 1, 2, 1, 2, 1, 2, 3. This is my pentyne. And like that, we'll have hexyne, heptyne, octyne, nonine, and decyne. So this is the way you go about naming each of these. Now let's look at the alkanols. How do you name the alkanals? You see, I'm just changing the ending from since alkane. I don't need to clean the whole thing. And the same thing we go about them now, the alkanals. How do you name them? From the first member. From the first member, we have COH. So what makes the difference in the alcohol is just the presence of the OH group. This is a group that makes them the OR group. So this OH group is what we call the OR group. So if we want to name it now, it's going to be, since this is actually a hydrocarbon, which one hydrogen has been replaced, we'll call it ethanol. 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 So the first member is actually like this, OH. And because it has only one carbon, is a met. And because it's all unsaturated, it's going to be methanol. Now, what of this? 1, 2, 3 with an OH. Only single bond is present. So we're going to call it like an alkane. So this is going to be 1, 2, 3 prop. And supposed to be an alkane, but they'll replace it with OH, which is an O. So we'll come and add the O here. Propanol. So for 4 carbon, 1, 2, 3, 4 with an OH. One, two, three. So this is going to be butanol. Butanol, because it is 4 carbon and it's actually an alkane, a butane, but they have replaced it with one hydrogen with OH. So now replace the E with OL. Ordinarily we can just say butane, but because there's an OH now, that's what makes the difference. Now come and say butanol. So we have pentanol, hexanol, heptanol, octanol, nonanol, and decanol. So this is how you name your what? Alcohols. Now, your alkanals. How do you name alkanals? Let's look at how we name alkanals. In naming alkanals, the difference simply is the presence of the CHO, that is C, all bonded to O, and the hydrogen. So in naming alkanals, what you do, you simply, the first member, C double bonded O, H, H. You change the ending of this OL now will become what? AL. So instead of having methanol, you call it what? Methanol. Now for CHOH, 1, 2, 3, 4. 3. This is what? Ethanol. It's actually supposed to be what? An ethane, but it has been replaced with an O and a double bonded O with a hydrogen. This group is what now makes it what? An R, so we'll call it what? Ethanol. So likewise we have propanol, butana, pentana, hexana, like that. And so on and so forth. When it comes to the ketone group, that is the alkanones. The alkanones. We don't have a methanol. We have ethanol, propanol, butanol, pentanol, like that, depending on the number of what carbon atom. And your carboxylic acids, your alkanoic acids. You have your ethanoic acid. Alkanoic acid, their presence is denoted by C double bonded O, OH. A presence of a double bonded O and an OH. This is what we refer to as the oic group. The oic group. So that when you have C double bonded O, OH, 1, 2, 3, 4, balance. 1, 2, 3. We'll call it what? Ethane. It's actually an ethane with an oic group, so ethanoic acid. It's an acid. This oil group is the ethanoic acid, the oic acid. So because it is an ethane, 2 carbon it, but it's all saturated with just the presence of this is going to be what? An ethanoic what? Acid. So this is how we'll go about naming each of the homologous series. Now we have come to the end of naming the homologous series, but what if you have, instead of having your O at the end, you don't have it here all the time. What if you have OH or a structure given to you like this? What if you have an attachment here and an attachment here? How do you name compounds like that? Is what we're going to be looking at in the next video. So you can go through the channel, you see the video whereby you name structures that have other substituents group. We're going to be looking at that in the next video. But please, if you are yet to subscribe, hit the subscribe button and do not forget to drop your questions in the comment section.